Hello, everyone. My name is Kelly Greenlee. I am the Community Outreach Librarian at Prince Memorial Library. Prince Memorial Library serves the towns of Cumberland and North Yarmouth, and we are very happy to be presenting this learning event for you this evening. We are talking about extreme weather. At Prince Memorial Library, we like to cast a wide net to offer programs that are of interest to a wide number of people. We do that through partnerships, and it is always a pleasure to work with partners because it makes the programs that much richer that we can offer. And we have worked with Chebeague and Cumberland Land Trust for quite a while at Prince Memorial Library, and we always love doing it. I have never worked with an organization that has more committed volunteers and more committed staff than Chebeague and Cumberland Land Trust. Penny Asherman is the executive director of CCLT. Prior to taking the reins at CCLT in 2022, she served as a board member for 18 years. She was a member of the Cumberland Town Lands and Conservation Commission and continues to serve as a liaison between CCLT and the town of Cumberland. Penny also serves on the board of the Maine Conservation Voters and Alliance, working on statewide environmental policy issues. She has a BA from Bowdoin College and a law degree and master's degree from Vermont Law School. Penny?
Thank you so much. I appreciate you hosting us this evening, Kelly. And thank you all for joining us tonight. CCLT has been conserving land and providing public access to nature for 37 years in Cumberland and Chebeague Island. And we're really excited tonight to be kicking off our climate series of events with our partners, Prince Memorial Library, the town's Town of Cumberland Sustainability Committee, and the Chebeague Climate Action Team. Our series is called Weathering Climate Change, Understanding Shifts in Our Local Landscapes. And it's a series of 9 walks and talks aimed at informing, engaging, and uniting our community members around local climate issues that are impacting us all. Some of the talks are online. Some of the talks are taking place in person out on the land. Others will be at Prince Memorial Library or on Chebeague Island. So we hope you will join us for some of those. And during the series, we're going to be learning about a lot of different topics. One of them is going to be the local climate action that's already taking place in our communities by our municipalities, our schools, and our nonprofits, and what more we can do collectively going forward to make a difference. We're going to be learning about our changing weather like tonight and coastline and the waters of Casco Bay, and how our forests and birds and marine populations are adapting to climate change, and the impact on and the role of our local farming and fishing industries, and how you can make a difference individually by using native plants on your properties and taking other positive climate actions. So I'm going to make a pitch for our next event, which is Saturday, March 30th. Derek Lovich from Freeport Wild Bird Supply will be joining us, and he's going to give a presentation and discussion about the rapid changes in Maine's bird populations due to the dramatic shifts in climate, and the whys and the hows and the what you can do to help our feathered friends. So this event's going to be at Prince Memorial Library at 1 o'clock on March 30th. Tonight, we're really excited to welcome Bill Danielson and Hannah Baranes for a discussion about sea changes and understanding and preparing for our Maine's coastal extreme weather events. We've certainly had our share of these lately, so it's a super timely discussion. And tonight, we're going to learn about some of the drivers of change in our climate, the role in our storms that we've had recently, and how they might shape weather events in the future. And then also we're going to address how to consider recovering from these extreme weather events, the causes, predictions of sea level rise, and how tide gauges and community science can help manage some of that risk. And then we're going to start off tonight, and I'm pleased to introduce Bill Danielson. He comes to us from Chebeague Island tonight. And between earning degrees in astronomy from Harvard and meteorology from McGill, Bill served in the U.S. Air Force as a weather forecaster in Oklahoma, Limestone, and Vietnam, and Maine, Limestone, Maine, and Vietnam. For 30 years, he taught meteorology, climate, and astronomy as a retiring professor emeritus from the University of Hartford. He's the author of articles, letters, and textbooks on weather and climate-related topics. And for a decade, he wrote a monthly newspaper column on Cape Breton's weather and hosted a monthly weather hour on CBC in Nova Scotia. And he served as board president in museums in Cape Breton and Wiscasset, and currently is a director of the Chebeague Island Historical Society and the Chebeague Climate Action Team. So I'm pleased to welcome Bill to our presentation this evening. Thank you.
Thank you, Pei, and I trust you can hear me out there. Let's hope that that's all working properly. I'm delighted to be here, and I thank the Land Trust for inviting me, and also the Climate Action Team on Chebeague for encouraging me to go ahead and do this. I've been a weather nut ever since grade 7, when my science teacher gave me the bug, I guess, and I've just enjoyed it as a vocation and avocation ever since. So it's been wonderful. It's also been fun to hear how much conversation there is these days about weather. I think the bug is really spread, assisted by the amazing weather we've had in the last few months. So there's just a tremendous amount of interest on weather and climate, which is very encouraging. I think that's one of the plus things about the stormy weather we've just been having. It has gotten people's attention. Is a scary time for the people who are interested in weather, and for everyone else for that matter too. And there's good reason, I think, for our sort of worriment about it, because we're used to the idea that climate has been changing a lot. We know that. We've been taught that 20,000 years ago. This might have been the scene at Chebeague. While there's a young fellow there standing on the edge of the glacier, just having missed the ferry to the mainland, Chebeague and all buried under thousands of feet of ice. So a completely different climate from the present time. Thousands of years after that, the climate had shifted dramatically, and the ice had disappeared, but the bedrock had not yet rebounded from the ice burden, and so the land was far below the sea, and extended quite a distance into Maine, and places like Chebeague, shown in the illustration on the right, were down at the bottom of several hundred feet of water. The temperature and the climate changed again and settled down after the rebound and so on. And for the past almost 2,000 years, up until about the beginning of the Industrial Revolution, the temperature was quite stable, relatively, staying in this window between about 2/10 above and 2/10 of a degree below the average for that time. And so there was a relatively quiet period going on. But if we add the most recent 200 years to this picture, you see that you see that the temperature has just taken off far higher at this point than it has been any time in the past 200 years. In fact, I've read recently that researchers are estimated that our current temperature hasn't been exceeded in the last at least 100,000 years, and maybe farther back than that. So, whoops, too much. There we go. And here's a closer up view of the temperature change in coastal Maine over the past 100+ years, showing a 3-degree increase in the temperature compared to the mean over that period, that's a pretty dramatic change, 3 degrees. And when you realize that that's applied to every temperature, so to speak, it's not just 3 degrees here and there. So how does that happen? How is it that the Earth has managed to start warming up? Here's a very quick look at the Earth's radiation budget. Sunlight, in the yellow, of course, is the sole source of energy for Earth from the outside. And the only way that Earth can get rid of heat is by re-radiating it out to space as heat radiation, or long-wave radiation, as it's called sometimes, or infrared radiation. Those are the brown arrows you see here. So if the brown arrows going and leaving Earth there are equal in size to the yellow arrow coming in, the solar radiation, then the temperature stays the same. If they are different, then it's going to be changing in one direction or another. The objects that do the work for the heat radiation are molecules in rather small quantities in the atmosphere. They are carbon dioxide, methane, and nitrous oxide primarily. These are in quantities of parts per 1,000, million, and even parts per billion. Very, very small amounts. They are transparent to sunlight, so they do not affect the solar beam coming in. However, they are amazingly good at absorbing and re-radiating energy at wavelengths and temperatures that are associated with Earth temperatures. And these are the critters. This is the pollution which has been rising in our atmosphere ever since the Industrial Revolution. You can see around, it's been going up through this whole period, this graph, but especially taking off for the carbon dioxide in the past 60 or 70 years. Enormous increases in these greenhouse gases, so-called because it was thought that they act similar to the glass in the greenhouse to keep the greenhouse warm. That's not a great analogy anymore, but that's where the term comes from. So the impact of this rising carbon dioxide is shown here pretty dramatically. For the past 800,000 years, CO2 has been somewhere between 180 roughly and 300 parts per million. No exceeding that all along until around 1950, when it was on its way upward fast. And now the latest number I heard was 424 parts per million. So it's even another notch or two higher on this graph. You can see that this is completely unprecedented in Earth history, really. Although the sun is very stable and does not change, we can't blame the sun for our climate warming, although some people have tried to do that. The amount of sunlight absorbed has certainly changed. And this chart showing the extent of Arctic sea level, sea ice, indicates how dramatic that has been. It's basically, we've lost about 50% of our sea ice since in the past 40 some odd years there. Ice obviously and snow is much more reflective than open water, and so the sunlight is reflected away and does not warm Earth if it's ice covered. But here it's able to, in open water, it's able to warm the water, which helps to keep or prevents ice from forming so rapidly, and it becomes a feedback loop where more of one becomes more of the other, or less of the other in this case. Another whole series of feedbacks involves water vapor warming of Earth's atmosphere causes more evaporation from the oceans and lakes and so on. And so we have this additional water in the air. When that water vapor condenses, it releases heat and warms the atmosphere further, which allows more evaporation to occur. The warmer the air, the more water vapor can be evaporated. Besides that, as the water vapor condenses, it forms clouds, and the clouds reflect sunlight, which decreases the amount of energy coming in, of course. And they also trap the long wave radiation, making the Earth warmer. So there are all kinds of entanglements going on there. In fact, the whole issue of clouds is one of the great questions about, one of the great unsolved problems about everything from day-to-day weather forecasting to long-term climate change. So let's take a look at more local conditions here, specific ones. Here's the temperature gain over the past 100+ years over the state of Maine, and it's 3 different zones that is mapped out by the Maine Climate Change Institute. By the way, that is the most amazing organization. I think Mainers should be so proud of the fact we have this Climate Change Institute, which just does fabulous work, and is known so well globally. Anyway, you can see that over the past century, the temperature across Maine has risen roughly 3 degrees Fahrenheit, and that's pretty much regardless of which end of the state we speak about. They're all starting at different temperatures, but warming up about at the same rate. Along with the warming has come and will come an increase in humidity, and as a result, the heat index. This chart indicates the change in heat index from the 2000s up to the year up to the 2050s. So we're right in the middle of that period. And Portland, it shows, is going from 4 events, 4 days per year, up to 13.5 days per year, with heat index over 95%, 95 degrees. The heat index is a combination of temperature and relative humidity. On this chart, the temperature is on the vertical. If you take a look, for example, at the 90-degree temperature, and then you choose maybe a relative humidity of 50% across the top, and you see those two meet, you're given a heat index of 95. Well, you see that 95 is in the light orange area, which is described as extreme caution. And so the prediction is for 13.5 days of conditions each year by 2050 of extreme caution days, and others higher. These are serious issues for human health. And another impact of the temperature rise is the length of the growing season, which, as indicated here, is changing from, on the average across the state, from around 100 and just under 140 up to well over 150 days per year between the last frost in the spring and the first frost in the fall. So the growing season is lengthened by 15.7 days. That's up till 2018, and you could probably tack on another day or two since then, and this will continue, as we will see later on. The warming also affects the general circulation of the atmosphere. The jet stream, for example, is an expression of the fact that there are horizontal temperature gradients between the north and the south. And as the temperatures change through warming, the jet stream is going to change as well. The illustration on the upper left is sort of a typical wavy jet stream well behaved, I guess you'd say, by historical standards or by present standards anyway. But as the temperature gradients begin to evolve into other kinds of patterns, so will the jet stream. So in the upper right, you see the waves have become a good deal steeper. There's also a break in the waves. In the lower left, it's a very deep loop that curves down over New England, it looks like. And in the lower right, the circulation has actually broken into a vortex. There's a whirlpool going on there around the Great Lakes. These vortices, which seem to be rather prevalent these days, cause the weather patterns to stop moving, really, and stall in place. The storms become vertically aligned, and you end up with the same kind of condition day after day. So you get a string of rainy days. A good example of that is here on the last few days of June, 4 years ago. Maine, you can probably see, is shaded in green a little bit there with a big fat L on it for low pressure. This map is showing conditions halfway up the atmosphere. It's at the 500 millibar level, it's called. The winds indicated by those arrows with feathers on their backs are rotating counterclockwise. This particular eddy sat in place for 3 days, June 28th through 30th of 2020. On Chebeague, I measured 6.1 inches of rain. Portland had 4 something, and anyway, there were numbers in that range that it just rained and rained and rained. That's typical of what happens in patterns like this. So these are changes that we well may be seeing more of down the line. The increased temperatures as Earth warms mean more energetic weather systems. And a good example of that is this jet that many of you may have seen this illustration from a month or so ago, when the jet stream over Washington, D.C. was measured at 265 miles an hour, I believe it was. And it carried jet airplanes to Europe at ground speeds of 800 miles an hour in places. Just colossal amounts of energy that the atmosphere is dealing with as temperatures rise. Storm tracks undoubtedly are going to change, although it's not clear just how they're going to do that. Here's a chart of storm tracks these days. It seems like they're really like Maine. And so as several studies have shown that as temperatures rise, the storm tracks will probably shift northward. So they would maybe move away from greater Portland, as they seem to there, and move to our north, which would bring in more warmer and moister air to our region as the counterclockwise weather systems come spinning by. Another effect of warmer temperatures is that, of course, things don't ice up so much, as I mentioned before. Here's a photograph, satellite image of the Great Lakes taken just 16 days ago, first day of March. And you see it's almost entirely open water. Well, those huge open sources are wonderful sources of energy for weather systems who are sort of lured in that direction. And so the presence of warm water bodies in places like this will help to change the storm tracks from normal to other kinds of patterns. In fact, we've had so many weather systems moving up northwest of us this winter. It's been a common experience. And let's explore that a bit further. The illustration on the left is a typical nor'easter moving up the coast. um, traveling to the northeast. And the circulation around it in the black arrows counterclockwise as always brings moist cold air from the Maritimes, Canadian Maritimes, down across the New England area. And that's a typical recipe for a snowstorm, of course. On the other hand, a weather system like the one on the right, which is sometimes known as an inside runner, running up inside the coast, is well inside the coast in this case, maybe taking advantage of the warm water over the Great Lakes. As it travels up, its counterclockwise winds bring in southeasterlies for us, which are moist and mild, and hence the rain conditions, which we've seen so much of this winter. And more people have said to me, why is it that we have so much southeast wind these days? We never seem to be getting the normal nor'easters, and I certainly agree with that observation. Precipitation is expected to change in the warmer future because the air can hold more moisture and the water table is going to work more vigorously. For us, in this illustration, coastal Maine is in green, you see, and the values are in winter and spring. The two green bars on the left are around 8% increase over the period from the 100-year period graphed here. The extreme situation, though, is much more frightening, I guess. A recent study showed that for Northeast states, the number of extreme precipitation events per year will increase by 52% over the period that is listed there at the top of the graph. And an extreme precipitation event is a rainfall or melted snow in excess of 1.5 inches in 24 hours. So although some studies have shown that it's expected there will not be as many extratropical storms, that is just regular low pressure systems in our future, the ones that do exist will be more intense. In fact, they've had similar predictions for hurricanes as well, fewer but more potent. This was, let me back up a second, no, never mind. This was all I had. I had another chart in there, but it's gone, it seems. Anyway, this is flooding after a rainstorm in December of 2019, showing the effects in Cumberland and also in Bethel. So we're all seeing these kinds of effects more and more in this warmer, wetter climate. Here's the Chebeague Stone Wharf on, I think this one was the December storm. We've had flooding in every one of the last 4 astronomical high tide periods over the last 4 months, December, January, February, and March. It's like the Northeast storms have been just timing it to hit us at extreme astronomical high tides each time. It's very curious. The wind from the southeasterlies certainly has a major effect on raising these tides, and Hannah will be telling you way more about that. We still will be getting snow in our future, not exactly like this one maybe in Waterville in 1898, but it will snow, and we'll get some blizzards, but they will be far fewer in number than what we're experiencing, what we have been experiencing in the past 100 years, for sure. And these wonderful data from of conditions in wintertime show the kinds of changes we're in for. 10 fewer snow days per year, whereas we can expect 10 more mud days a year, which kind of summarizes it in an interesting way. Ice days are days that temperature stays below 32 the entire day, and there have been 5 fewer of those in the past 100 years, and you can project these numbers pretty well into the future, I think. Snowfall decline is expected to look like this, with more than a 40% decline along the coast, and somewhat less in northern Maine. So the skiers had some hope, perhaps, but it looks pretty grim for snow lovers on the coast. In these more powerful storms, we can expect more damage to trees, forests, and so on. This was after the October 2019 storm down at Deer Point in Chebeague. That's my wife wending her way through the damage, and get a terrible scene of destruction there, which is very disturbing to have to imagine more of in the future. It also raises issues of wildfire when you have huge piles of dead and dying trees in a situation like this. So in summary, our future weather in Cumberland and Chebeague is liable to be warmer by as much as 10 degrees by the year 2100, depending on what happens in terms of our controlling emissions. It's going to be wetter with higher humidity, more downpours and floods, cloudier and hazier, including with the southeast, the southerlies adding to that, but also, and I didn't mention it, the problem with western wildfires bringing their smoke in our direction, as they did last summer. Less snow, drier at times, and the weather just simply more erratic, with times where it jumps from one regime to another for a few months and then back again. Windier and more powerful systems coming through and then sometimes stalling. And I'll conclude by just suggesting this, that it's up to us to reduce the greenhouse gas emissions that we have been putting into the atmosphere in the first place. And so our future climate is really up to us. We can take the low road, so to speak, the lower emissions road, which is the higher moral road, and end up with changes of maybe 2 or 3 or 4 degrees Celsius or Fahrenheit by the year 2100, or the higher emissions path. And it truly is up to us. Well, thank you very much for your time. And back to Penny.
Thank you so much, Bill. A lot of information to absorb. Thank you so much for doing all the research and presenting it to us in a way that we can all understand. And we can also look out a window and see a lot of the changes that you were talking about. Having mud season in mid-March is definitely different. And we're waiting for our frogs to wake up a lot earlier than we normally do for our frog night.
That's right.
So I'm going to introduce Hannah Baranes. She is a coastal scientist in the Climate Center at the Gulf of Maine Research Institute. Her focus is characterizing coastal flood risk in a way that's translatable to local and state level decision makers. And some of her projects include developing a flood risk assessment tool for working waterfronts, improving flood forecasting by installing tide gauges alongside community science, education, and municipal engagement programs, designing statistics for statewide coastal flood risk model, and statistical modeling of water levels in tidal rivers. She's also serving as a member of the Maine Climate Council Scientific and Technical Subcommittee, and she was the review editor of the 5th National Climate Assessment and co-authored the City of Boston's Regional Climate Projections Report. She received her degree in Earth Sciences from Dartmouth College and master's and PhD in Geosciences from the University of Massachusetts Amherst. Thank you so much for coming tonight, Hannah.
Hi, everybody. Penny, thanks for that introduction, and thanks to all of you for being here on a weekday night. I'm going to go ahead and share my screen. See, always the spookiest part of presentations. Share, and then we'll go full screen. All right, Penny, how's that looking?
That looks great.
Okay, great. Okay, no need to introduce myself. Took care of that already. So I am a research scientist at the Gulf of Maine Research Institute in Portland, Maine. If you're not familiar with us, our work aims to develop and deliver collaborative solutions to global ocean challenges. And those of us at the acronym I use is GMRI, we work on a whole host of global ocean challenges ranging from seafood sustainability to promoting healthy ocean ecosystems to ensuring Maine's marine economy can thrive into the future. And perhaps one of the foremost global ocean challenges of our time is climate change. And that's what I work on. So before diving in, climate change can be this really anxiety-inducing topic. And there's research showing that climate anxiety can sometimes lead to action, but it can also lead to paralysis, whereas hope, on the other hand, is much more likely to lead to action. And no matter how dire the situation may seem, action is critical because truly every 1/10 of a degree of warming matters. There's no point where it makes sense to throw up our hands and give up and say the situation's too bad. And there are also about 2 billion people alive today who are under the age of 15. So 2100 is not some abstract year for them. And so as an Earth system scientist, sometimes I get a little bit nervous talking to the public because my work focuses on what's going to happen more than how to solve it. So I get asked all the time whether I'm hopeful or optimistic, and I've actually often gotten criticized for perhaps not appearing anxious enough. But I actually learned something just this morning that I've been thinking about all day and gave me a little bit of perspective here. And it's pretty blank slide because, again, I've just been kind of chewing on this since this morning. But as Penny mentioned, I'm part of the group that develops the scientific and technical guidance that the Maine Climate Council uses to develop the state's climate action plan. And if you're not familiar with it, go check it out. It's called Maine Won't Wait. It's been hugely impactful on policy and received national recognition. But anyhow, when the council met this morning after the scientists went around and presented all of our updates, Dr. Susie Arnold, who some of you might know from the Island Institute, came on and talked to us about the science of hope. And she shared that research on hope is tied to having a goal and then having agency and a pathway to work towards those goals. So for me, I guess I've always wondered why I don't feel more anxious, but because when I look at the big picture of climate change, it's scary. But my day-to-day is all about using Earth systems knowledge that opens pathways for other people to take targeted and incremental action. So I have goals and agency, and I think that's why I'm hopeful. So thinking about all of you who are on this call tonight, my point here is that I don't necessarily have the expertise to give you all of those elements that you need to have hope and take action. But the fact that you're here and engaging and you're connected to this great local organization and hopefully will come to more of the presentations, that's an absolutely critical first step towards building the agency that can lead to hope. So after this, I really hope you all continue connecting with each other and seeking the expertise that'll help you build those pathways to action. And again, if you need some inspiration after this talk, Maine Won't Wait, or like any of the Maine Climate Council's material on their website is a great place to start to learn about all the things that are going on in the state. Okay, so with that, we'll jump into, I think my job is to share some information on what's going on from the ocean side of things. And Bill had talked mostly about what's going on in the atmosphere. So something that's on everybody's mind is all of the coastal flooding we've experienced so far this year. I haven't updated this to show what happened during the recent March storm over the weekend, but the January 10th and 13th storms led to some of the highest water levels that have ever been recorded along coastal Maine. So in thinking about what's happening, I get asked all the time, like, is this the new normal? Was this a 10-year storm, a 100-year storm? Like, what can we expect in the future? Is this showing us what's to come? And bear with me here. I think we'll get into the science behind it a little bit. I think that's helpful for kind of understanding what's going on and what's to come. So when we see an extreme coastal water level, there are a whole bunch of different elements that combine to create that high coastal water level. So on top of whatever kind of the long-term average sea level is, sea level varies year to year. It goes up and down as large scale, as currents shift and as large scale atmospheric patterns change. And then there's this long-term rise in sea level that we're all familiar with. And these, I'll come back to this, but these two elements were absolutely critical in creating these severe flooding situations this year. Then on top of whatever sea level happens to be doing in a given year, tides raise and lower water level, and storm surge hits on top of a high tide to drive flooding. So in Maine, our tides are big relative to the height of storm surge. And so how bad flooding is from a storm has everything to do with what the high tide happens to be the day a storm hits. And like Bill alluded to, we've gotten pretty unlucky this year. So the January 13th storm, for example, was a relatively moderate surge hitting on top of a very high tide. The January 10th storm was the opposite. It was a more moderate tide and a very high surge. Mm-hmm. And then on top of that, there's waves. So on the, for now that we've been seeing more storms that have winds coming out of the southeast, a lot of Maine's coastline is really exposed in the southeast direction. So particularly on January 10th, the wave impacts were really extreme mid-coast and down east and on the exposed southeast facing shorelines of southern Maine. And then there's this kind of like last impact that I think we don't think about so much in southern Maine, but for a lot of communities along Maine's coast, they are impacted both by coastal flooding and by freshwater flooding. And now that these storms are bringing rain and warm weather instead of snow like we're used to with like the typical nor'easter, these communities on tidal rivers are getting flooding from both directions. And in Portland, actually, one of the impacts that really surprised me was we don't have a big river emptying into Portland, but having 2 inches of rain fall at the same time as coastal water level was high caused a lot of storm drains to back up. So like Congress Street, for example, was impassable in a lot of pretty like high inland locations. So let's come back to that sea level piece I mentioned. This is showing the average annual sea level, so yearly average sea level since the early 1900s, which is how long we've had a tide gauge sitting out in Portland Harbor. And you can see, like I said, there are these wiggles. Annual mean sea level goes up and down and up and down. And in 2023, in addition to this long-term increasing trend, and in 2023 and in early 2024, sea level was higher than it's ever been. So when we look at the total water, like the ranks of the January 10th and 13th events, they were the first and fourth highest water level that's ever been recorded in 120-ish years at the Portland tide gauge. But if we looked at these events without sea level rise and variability, so instead if we said, let's say sea level were the same every single year, there would have been about 25 events similar to January 10th, and January 13th would have been similar to the blizzard of 78. So I wouldn't say that these are a new normal, but these are the new types of severe events that we do need to plan for with sea level being higher. And just as a note, we also experienced one of these spikes in sea level in 2010. That's the spike that I'm holding my cursor over. And there's been some work that's come out since then saying that that was likely because of a temporary slowdown in the Gulf Stream. So normally the Gulf Stream is this fast moving current that pulls water away from the Atlantic seaboard. When it slows down, it's like turning a hose from a jet setting to a shower setting, and water kind of sloshes back up against the Atlantic seaboard and raises sea level. And there was something called the North Atlantic Oscillation that was consistently in a negative phase, which just causes there to be like prevailing onshore winds that pile up sea level. We don't know what's happening right now, and we don't know whether this spike is going to go back down. So yeah, something we'll be working on trying to figure out what's going on with high sea level in 2023 and 2024. The reason, before I go ahead, the reason that's so important is like thinking about what the impact of just kind of the historical sea level rise we've seen in the context of what's to come. So if I take the curve or the graph that is on the left here, now that black line is collapsed down into this black line on this plot. So in the last 100 years, we've seen about 8 inches of sea level rise in Portland, plus an additional like 4 inches from the spike in 2023. And what should stand out is that those numbers are relatively small compared to what the state of Maine is committing to manage in terms of sea level rise in the future. So Maine has committed to manage 1.5 feet of sea level rise in 2050 and 4 feet in 2100. So yeah, those numbers are big relative to the big impact that 8 inches has already had. So this is a really important time, particularly as we're starting to rebuild after the coastal flooding events of this year. It's an important time to consider how high to rebuild, how strong to rebuild, and in some cases, perhaps whether to rebuild at all. And okay, so I'm going to just get a little bit into why this is happening. So this is sort of another view of that same plot, but instead, in that last plot, what I was showing was just sort of an intermediate scenario for what might happen in the future in terms of sea level rise. In reality, there's like a whole lot more possibilities out there. And the reason that is that it's not about, it's not all about necessarily greenhouse gas emissions accelerating. So historically, most of the sea level rise we've seen so far has come from mountain glaciers melting. That's shown by this blue bar. Oh, the black bar is the total amount of sea level rise. This is a little bit outdated now. So the blue bar is showing the contribution from melting mountain glaciers. The red bar is showing the contribution from thermal expansion. So that's just as ocean water warms up, it takes up more space, and that causes sea level to rise. What stands out here is that so far relatively little has come from Greenland and Antarctica, like about 2 inches. And those are those massive ice sheets that sit on top of the North Pole and the South Pole. So this sort of range in possibilities, looking out to 2150, that has everything to do with how much meltwater Greenland and Antarctica contribute. Because if the whole things were to melt, there's over 200 feet of potential sea level rise locked up in that ice. And that last slide Bill showed is really important, where human decision making around emissions will not only determine how much we warm, but it's going to determine whether we cross thresholds of instability where even if we eventually do reduce emissions, these ice sheets might just keep melting. All right. So let's talk a little bit about what we can do about it and what kind of work I do at GMRI to work on some of these really challenging problems. So I work in a group called the Climate Center at GMRI, and our approach is really to try and deliver climate solutions centering stakeholders with this three-pronged approach of developing science that can be used to inform decision making. That's kind of the bucket I sit in over here, and I'll talk a little bit more about a couple of my projects in a bit. We have a team that just works on engaging with municipalities, businesses with a focus on working waterfront, and students and educators, so that information is connected with the people who make a difference in their communities. And then we also work on actually trying to deliver climate solutions. So we have someone who works on financing climate projects. We develop data projects for decision support. And then these last two in brackets, coastal planning and greenhouse gas emissions mitigation. That's sort of, we're hoping to hire people soon to work on those problems. So I lead the Coastal Hazards and Sea Level Rise Lab at GMRI. And like I mentioned, our goal is to improve local flood risk characterization in a way that can inform decision making. So rather than saying, sea level is going to rise 1.5 feet by 2050 in the state of Maine, that's not necessarily actionable information. It's really important, but it doesn't tell you how to prepare for the storm that's coming next week, how high to rebuild your furnace, what the first floor elevations of your building should be, what bridges to worry about, et cetera. So I work on various tools that kind of help develop that localized information that can be translated to action. So like I mentioned, I work on the Maine Climate Council, where we develop information that we give to a group of state and industry leaders who develop Maine's climate action program, and it helps them kind of target their action towards the most urgent climate-related problems in the state. I'm working on developing a flood risk assessment tool for working waterfronts that property managers can use to say, like, if a heat pump got damaged during a storm, or I'm installing outlets, or my furnace is gonna bite the dust soon. How high do I need to elevate these critical utilities that keep the waterfront running? And then the project that Penny alluded to in the beginning, which I think is pretty relevant to Chebeague, we've also gone up and down the Maine coast installing tide gauges that measure coastal water level, that are co-located with community science, education, and municipal engagement initiatives. So I sort of forgot I was supposed to talk to you all about that. So I threw on a few slides here at the last minute that I often show kids when I talk to them. This is a really fun project, in that when we go into these communities, we work with local teachers and students to get them involved, because those, I think in my mind, those are some of the most important people in each community to involve in climate work. And so the idea is, when there's a coastal flood coming, it's often like you can respond a lot better to coastal flooding events if you know exactly what the impacts will be in your community. So you can preemptively close roads, maybe, like, for example, on Union Wharf, one of the working waterfronts near GMRI, we knew which propane tanks were going to flood, so we went and we disconnected them and tied them down so they wouldn't float away. There are all kinds of things you can do to mitigate risk if you know what to expect. So the National Weather Service actually does put out flood forecasts. So for example, the Weather Service might say water levels are going to reach 13.5 feet on Tuesday. But that information is not all that helpful if the town, the municipal officials, and EMA doesn't really know what 13.5 feet mean. And so we are installing these tide gauges, which measure coastal water level. They both actually help weather forecasts, help the National Weather Service forecast water levels more accurately. They use them to check and improve their models. And we have community members go out and take observations and submit them to a community science database. So now in a bunch of places we have water level and photos of impact. And we're working on developing data products where we put all those things together and feed them to emergency managers and decision makers to help them prepare for flooding events. So now we get flood forecasts in more places. We've installed gauges in Boothbay Harbor, Port Clyde, and Machias, in addition to Portland. And ideally, in the future, the town hall will know which roads to close and which homes and businesses to alert. All right, that is all I have got for you all. Thank you for being here and for listening.
Thank you so much, Hannah. Really interesting and amazing photos that you've collected over just the past couple of months even. We do have a question that came in, and the question's about considering the anticipated massive increases in rainfall. The person imagines that the removal of 2 dams on the Royal River might help ameliorate the coming floods. And a real live river has a greater capacity to let water escape to the sea. And can we get behind the ongoing commentary on this subject as it clears the Army Corps of Engineers analysis and dams removal? So I'm hoping maybe one of you might have some thoughts on that you could share with us.
Bill, I think you're muted if you're trying to answer.
Okay, yeah, I think it's not a topic that I can shed any light on, I'm afraid.
Yeah, seconded. I don't know anything about the dam removals.
All right, well, hopefully we can get that information. I know we can reach out to some of the people in Yarmouth that are working actively on this project, so hopefully I can get back to you about that. I want to thank you. If there's any other questions, definitely send them our way. Let's see, I think there's another one here. When thinking about Cumberland and Chebeague Island specifically, are there any particular hotspots that you are worried about in regards to flooding or coastal beach erosion today or in the coming years? That's a good question.
Well, certainly there are a number of places on Chebeague. We're taking pictures at 6 or 7 of them at every high tide sort of warning time, and they include the Hook, of course, the Hamilton Beach, Jenks Beach, and farther along, and the Stone Wharf being a critical part of our whole infrastructure is at risk. So yeah, there are plenty of them on Chebeague.
Hannah, does GMRI also have grant programs that help? I know you're helping municipalities make decisions and have things on their alert system, for storms that are coming in, but do you also help municipalities take action on some of the infrastructure that they need to be protecting?
We do not. No, we do. We just hired a climate financing specialist who helps communities basically like finance climate solutions, and we will often partner with engineering firms to sort of lead the risk assessment and community engagement process, and then like have the engineering firms go and like lead the design of a solution.
Great.
Does that answer your question?
Yeah, I think,
Okay.
that's something that's on the minds, I think, particularly of people on Chebeague Island. So there's major infrastructure that is flooding and it's their way on and off the island. So it's really important that not only they can anticipate what's going to be happening in the future, but come up with solutions that are going to stand the test of time. So Bill, I don't know if you have any thoughts on that.
No, not right at the moment, I guess.
Okay.
I have a question for you. Hannah, I'm wondering what kind of success you've had with your community science project. Like, do you have a lot of participants? And if people are interested in getting involved in that from the community science end of things to do their own research and help you out, how can they do that?
You can visit investigate.gmri.org. That is our community science platform, and anyone can sign up for an account and submit observations, whether or not you are in one of the communities that has a tide gauge. And yeah, we've had lots of great engagement and participation so far. In particular, we've had school groups going out at each of the month's high tides this year.
I bet the
And
kids
maybe
love
for
that.
example, like, yeah, as a success story, like the city of Portland put backflow stoppers or one-way valves in their storm drains to try to stop flooding in Back Cove during high waters. Like, so, water doesn't just spill over from the coast into Back Cove. There's higher land in the way, so it's actually water that's just backflowing through storm drains that floods that area. And we were able to use community science photos to essentially like identify exactly how high water gets to start stressing that system. So that's just one example of how those photos have helped inform management decisions.
Great. Sounds like Bill's already doing that on Chebeague. So that's great. I think we need to take some photos of Cumberland coast as well. Definitely some of the roads in Cumberland have been flooding also, even though we're, a little bit inland on some of our roads. So it's been a very interesting winter, definitely. Well, I want to thank you all for arming us with some information tonight and giving us some hope, as Hannah said. And I want to leave you with a call to action to join us on some of these other events that we're hosting over the next 6 months, because knowledge is power. And I think collectively we can make a difference. And I hope that learning some of these hyper-local facts and information will help you be inspired to take action yourself as well. So, Kelly, I'll leave it back to you.
Yep, and I'll just remind people, thank you, first of all, thank you, Hannah, and thank you, Bill, for your presentations. They were fantastic. Penny, thank you for your hosting or helping me host. And I just want to remind everybody that you can look at the upcoming Weathering Climate Change series on the Prince Memorial Library website page at princememorial.org or on the CCLT website page at ccltmaine.org. There's a stellar lineup of speakers joining us for virtual and in-person events. So I highly recommend you take a look at the series. Our next event is Saturday, March 30th at 1 o'clock in the afternoon. Here at Prince Memorial Library, we'll be hearing from Derek Lovich about Maine's changing bird populations. So that'll be really interesting. Until then, thank you very much. Thanks everybody for joining us. Thank you, Hannah. Thank you, Bill. Thank you, Penny. And good night.
Good night.